term is diagonally dominant. What does it mean? It means if for the equation, if the diagonal elements, that is a11, then a22, then a33 and dot dot ann, if for each of the elements it seems that this element, its magnitude is greater than the sum of the magnitude of other coefficient, then we will say this is diagonally dominant or strictly diagonally dominant if it is strictly greater than, and if it is greater or equal to, then we will say it is diagonally dominant. That means the condition for diagonal dominance would be, for the first equation it will be a11 modulus of a11 greater than the sum of the other coefficients, that is magnitude of the sum of the magnitudes of other coefficient, that is a11 greater than a12 plus mod a13 plus dot dot plus mod a1n. This is for the first equation. For the next equation, the diagonal element is a22, so a22 would be greater than mod of a21 plus mod a23 plus dot dot plus a2n, right? Similarly, for the nth equation it will be ann greater than an1 plus an2 plus dot dot a n comma n minus 1. This one. If this happens, all these conditions, total nth conditions happens, then we will say the system of equations is strictly diagonally dominant. Here we are using the strict greater than sign. If it becomes greater or equal to, then we will say it is diagonally dominant, and if it is strictly greater than, then we will say it is strictly diagonally dominant. Okay. Now we are moving to the procedures. The first procedure is called Gauss elimination method. We have total 3-4 methods of solving the equations. Okay, Gauss elimination method. Now the method has been discussed in the book by taking at first n equations, then by taking 3 equations. So I am starting with by taking 3 equations because it will be easier for all of you to understand the process, and especially in examination, maximum the 3 equations will give in the exam, not more than 3 equations. So starting with, suppose we have a system of equations a11x1, 3 equations with 3 unknowns. a12x2 plus a13x3 equals b1. Then a21x1, a22x2 plus a23x3 equals b2. a31x1 plus a32x2 plus a33x3 equals b3. Okay. Now this is our given equation. At first we are renaming the coefficients by putting some upper power. Okay. So for this is our first stage. So we are naming it like this. First coefficient as a11 upper 1. Then a12 upper 1. As this is our first stage. So renaming them like this. Okay. Now we will take the first equation and multiply it so that this equation and this term and this term will vanish from the second and third equation. So what we are doing, multiplying the first equation by using first equation, we just want to vanish this term and this term. Okay. So multiplying the first equation by minus a211 by a111, okay, and adding with the second equation and adding with the second equation, and again multiplying the first equation by minus a311 by a111 and adding with the third equation. Now check, whenever we are multiplying the first equation with this term a211 by a11 with minus, so a11 will be cancelled out, it will become minus a21x1, here it is plus a21x1. So whenever after multiplying we are adding this with the second equation, the first term will be vanished. Similarly, by multiplying the first equation by a31 by a11 with a negation, then it will a11 will be cancelled out and it will be a31x1 minus a31x1, and this is plus a31x1. So whenever we are adding these two, this term will be vanished. So after doing these two steps, what will we get? We will get the three new equations. The first equation will be unchanged, so it will become a11 x1 plus a12 x2 plus a13 x3 equals this. And the second and third equation will be, the first x1 terms will be 0 plus a22 2x2 plus a23 2x3 equals b2 2, right? And then a32 2x2 plus a33 2x3 equals b3 2. Now we don't know what a22 is. A22 will be, after that calculation we will get a22. This is why we have used this upper power 2 here, because we are on the second stage. So a22 2, we have to calculate that a22 value, a33 value similarly. So for the second and third equation, check the x1 term gone, right? Now what will we do? We will take the second equation. Then by using this term, we want to remove this term. So what will be the term we are multiplying with this, so that we can get rid of this term? So it will be, we will multiply this term by minus a322 by a222, right? Then whenever we are multiplying this by using this coefficient, so a22 will be cancelled out and it will become plus a32x2 and minus a32x2, and here it is plus a32x2. So whenever we are adding this term will be cancelled out. And the second equation will be the same. Third equation will become some a33 3x3 equals b3 sum 3, right? Because this term there will be no this term. Now from this equation we can easily get the value of x3. Now getting this value of x3 and put it over there. So there, by putting the value of x3, we can easily get the value of x2. Now put that x2 and x3 over there. So we will get the value of x1 easily. So this is the whole procedure, okay? Just by multiplying, take one equation, multiplying with suitable constant so that we can get rid of the first variable from the remaining equations, and apply this iterative method until we get a single variable equations, okay? So we are trying to solve, at first try to solve few equations. So write down example. Solve the system of equations by Gauss elimination method. Solve the system of equation by Gauss elimination method. 2x1 plus 3x2 plus x3 equals 9. x1 plus 2x2 plus 3x3 equals 6. 3x1 plus x2 plus 2x3 equals 8. This we have to apply Gauss elimination method to get the result. So check, this is our first equation. This is the first term. Using this term, we want to make this and this vanish. So what will be the multiplying term? That is what would be, we will multiply with the first equation so that we can get rid of this and this term. multiplying the first equation by minus half, right? Because there is 1, so it will become minus 1 by 2, and for this equation it will be minus 3 by 2. So multiplying the first equation by minus half, comma, minus 3 by 2, and adding respectively with the second and the third equations. So what will we get if we do that? The first equation will be unchanged, so it will become 2x1 plus 3x2 plus x3 equals 9. Now multiply it by minus half, so it will become minus x1, then minus x1 plus x1 will be 0. Our purpose is served. Now for this term, if we multiply it minus half by minus half, so it will become minus 3 by 2. That means it will become 2 minus 3 by 2 x2. So writing it here, 2 minus 3 by 2 x2. Then for this term, it will become 3 minus half x3. So 3 minus half x3 equals, for the right hand part, it will be 6 minus 9 by 2. So 6 minus 9 by 2. Okay, this is the second equation. We will solve it later. Now get the third equation. It will become, the first term will be 0 obviously, because if we are multiplying it by minus 3 by 2, so minus 3x1 plus 3x1, it will become 0. So now for this one, this will become minus 9 by 2. That means this is 1. So 1 minus 9 by 2 x2. And for this term, it will become 2 minus 3 by 2 x3. And for the right hand side, it will become 8 minus 9 into 3 by 2, that is minus 27 by 2. Right? Now simplify it. So we will get, first equation will be the same thing. 2 minus 3 by 2, that is 0.5. So 0.5 x2. 3 minus half, that is 2.5. And 6 minus 9 by 2. 1.5. Then 1 minus 9 by 2 minus 3.5. Then 2 minus 3 by 2, that means 0.5. And 8 minus 27 by 2 minus 5.5. Right? So this is our second set of equations. Now check for the second and third equation, there is no x1. Now we want to remove this, from using this term we want to remove this term. So what will be the multiplied value? Multiplying the second equation by, it will be minus of, then minus 3.5 by 0.5, right? This quantity, that means minus minus plus, and 3.5 by 7 by 0.5, that means ultimately 7. So by plus 7 and adding with the third equation. We get 2x1 plus 3x2 plus x3 equals 9, the same thing for the first equation. For the second equation, it is also the same thing, 0.5 x2 plus 2.5 x3 equals 1.5. For the third equation, the first term obviously will be 0. For the second term, it will be 0.5 plus 7 into 2.5, right? So 0.5 plus 7 into 2.5 x3 equals minus 5.5 plus 7 into 1.5. So just simplifying the third equation, we will get 0.5 plus 7 into 2.5. It will become 18. So 18x3 equals, on the right hand side we got 7 into 1.5 minus 5.5. So we will get 5. That means this one and this one. These three represent the final stage of the procedure. So from here we can easily get the value of x3, which will be 5 by 18. Now get the value of rounded off value of 5 by 18. So it is 0.27777 and so on. So we will take it as 0.2778 by taking fourth decimal places approximately. So 0.2778. Now put this value of x3 over there, here, to get the value of x2. So from here x2 will be 1.5 minus 2.5 into that value 0.2778 whole divided by 0.5. Now calculate it. The rounded off result is 1.611. Now put that x2 and x3 over the first equation. So we will get x1. This will be 9 minus that value 0.2778 minus 3 into 1.611 whole divided by 2. So it will take the value 1.945 after rounding off. This one, okay. So these are the three values of x1, x2 and x3. This is the required solution by Gauss elimination method. Okay. This is the whole procedure how to solve it by using Gauss elimination method.